Hello all. Today we are going to see a question from GATE 2017 Mechanical Paper 2, question number 10. So you are being given a steel bar in this particular condition where the ends are fixed. Okay, so the two supports are fixed and it is subjected to an increase of temperature, which is that is the change in temperature is 100 degrees Celsius. So if you are given what are the coefficient of thermal expansion and the Young's modulus here, so you need to find the magnitude of thermal stresses in MPa. So before going into the problem, if you want to know more details about thermal stresses due to expansion or contraction, you can check out more details in NPTEL course Strength of Materials by Professor S.K. Bhattacharya from IIT Kharagpur. So let's go ahead with the problem. So generally the thermal stress is given by this particular formula where it is a function of Young's modulus and coefficient of thermal expansion and the temperature change. Okay, so these are its Newton if your sigma, that is your stress, is in MPa. Okay, so let's go ahead and you see how to use this particular formula. So now what are we given here? That is the change in temperature is given to be 100 degrees Celsius. So now this is change in temperature, not the absolute temperature. So even if it is in Kelvin, it would have been the same value. Okay. However, based on this change in temperature, you are given what is its alpha, that is a coefficient of thermal expansion. Okay, so this is one thing, and you are given its Young's modulus, that is E, to be 200 GPa. Okay, so let's convert it into MPa so that you get finally your thermal stresses, they need it in MPa, so you'll get it in that form. So this whole value into 10 raised to c, so you will get finally 2 into 10 raised to 5 MPa. Okay, so let's utilize this formula. So your thermal stresses is E, that is 2 into 10 raised to 5 into alpha 11 into 10 raised to minus 6 into your change in temperature, that is again 100. So when you solve this, you are going to get 220 MPa. So this is your final answer. Let's see how we can modify this problem a little bit to make it more tricky. So you are given a bar like this, which is actually fixed at both ends. In this particular case, you are given a bar which is actually fixed at both ends. Therefore, when you actually give some uniform heating, let's say some Q dot, so therefore this bar will try to expand, right? So it will have, but it is fixed at other ends. Okay, so when it tries to expand, but it can't expand because it is fixed at other ends, then the stresses will be developed. Okay, so now if the same bar is given Q uniformly, okay, but now your ends are not fixed, it is free. Okay, that means it will expand freely, so there won't be anything to resist. Therefore your stresses will be developed will be zero actually, because nothing will be developed because there is no resistance. If there was a resistance, then only your stress will be developed. So same problem, if your ends are free. So if the same problem was given with ends are free, then your answer would have been totally different. So I hope you understood the concept. You can check out the NPTEL lecture for more detailed analysis on this topic. Thank you.